Alright guys, welcome to lesson 4. In this lesson we're going to revisit graphing quadratics in standard form, but this time we're going to do it without the graphing calculators or the internet websites that graph for us. So we also need to know how to graph these things by hand whenever we don't have the technology available. So we talked about how to graph quadratics in vertex form 2 lessons ago on lesson 4.2. But we didn't really talk about how to graph standard form equations by hand, and that's what this lesson is all about. So, by the end of today, you guys should be able to find the vertex of a quadratic function when it's in standard form. You should be able to find the y-intercept of a quadratic function when it's in standard form. And then we should be able to use those two things to actually create a graph. We've already done this, the last bullet, find the roots of a quadratic in standard form. That was our very first lesson in 4.1, and that's where you use the quadratic formula. That's an optional step. You can do that also to find 2 other points on your graph so that it makes it a little bit easier to graph the actual parabola. All right, so let's go ahead and begin here. First of all, talk about the y-intercept when we're in standard form. Now, y-intercept is the place where your graph touches the y-axis. When you're at the y-axis, the x value is 0. Okay, but I want you guys to see it here then. If I let the x value equal 0 in this equation, then 0 times the a and 0 times the b is just going to make those go away, and you're going to be left with y equals c. So when you let x equals 0, the y-intercept is just going to end up being this number right here. And so when you're in standard form, the y-intercept is simply the c value. So the technical process is you're plugging 0 in for x and solving for y. But when we are in standard form, we don't have to do that. We can just take the c value and know that that's our y. So in this problem, for instance, example 1, the y-intercept would be when x equals 0, y is that number right there. And there's my y-intercept. Pretty straightforward. So for this one, what would the y-intercept be? You guys think about it. You don't have to write it down if you don't want to. You can just think about the answer mentally. But hopefully you understand that the x value would be 0, because that's what it always was whenever you're trying to find a y-intercept. And the y value will be the c value, which in this case is 9. So that would be your y-intercept. All right, move on to our next question here. Now, I'm going to review with you guys for a second. Excuse me. All right, I'm going to review with you guys just for a second here how you change a standard form equation, like this one up here, 3x squared plus 12x plus 5, into a vertex form equation we have down here. But the reason I'm reviewing that with you guys is because I want you guys to watch what happens to this number here. Okay, so in the second step, nothing happens to it. But in the third step, that number changes. It becomes 4 because it got divided by 3. So what we do is we take that b value and we're going to divide it by the a value first, right? So you take the b value, divide it by the a value, and that's why we have 4 here. Then when we move on into the fourth step, nothing happens, but down here something happens again. The 4 now becomes a 2, and that's because in our process here of completing the square, we take half of this middle number, so we divide it in half. So I'm going to put a 2 here down on the bottom. And then finally, if I were to ask you guys to graph this, thinking back to your lesson from 4.2, what would the vertex be? Well, it's this number and this number put together, but don't forget we changed the sign on the x value. So we change the sign. So what I've just done here is I've created a formula by following what happens here through the process. And this is a formula that will help us to find the x value of our vertex at any given time. So the process is take your b value, divide it by the a value, then divide that by 2, and then take the opposite sign of it. In other words, negative b over 2a. And that will give us the h value, or the x part of your vertex. Now that we have a formula, we don't have to go through that whole process anymore to find the x value, or the vertex. What we can do instead is to find the vertex in standard form, we can just use the formula to find our h, and then we can plug that in to find our k. So when you have a quadratic equation in standard form, what you're going to do is you're going to plug in the b and the a into this formula, and the answer you get is going to be the x value of your vertex. Find the y value, you take that x value and you plug it into the equation and solve for y, and that will tell you the y part, and you'll have your total vertex. Okay? So let me demonstrate that for you. But before I do, actually, I guess we're just going to put it together with graphing. So we're going to graph a quadratic in standard form in the following way. We're going to start by finding the vertex. So to do that, I'm going to begin by plugging my b and a values into this formula to find the x value, or the h value in this case, of the vertex. Then I'm going to take that answer and plug it back in so I can find the y value that goes with it. And that will tell me the vertex. Once I have the vertex, I'm going to find the y-intercept. And remember, the y-intercept is just this number right here. After that, we should be able to get a pretty good sketch of our graph. Something I think I'd like to add on here, though, that's not already on here, is don't forget the a value. It still applies here. Positive a is a happy face. The negative a is a sad face. Now, you don't really need to know this in order to do the problem, but it might help. Okay, so if the number in front is a positive, then we have a upwards facing parabola. If it's a negative number in the front, it's a upside down one. If you do steps 1 through 3 correctly, this is going to happen automatically, but it's a nice way to check your work just to make sure that you're on point. All right. Now we'll talk about this little star note down here in a minute, but for now we'll just leave it at that because I feel like we're adding too much information without enough practice. So let's go ahead and jump in. So I want to ultimately graph this parabola, but the first thing I want to do is I want to find the y-intercept and the vertex. So first of all, the y-intercept is right there. So we have 0, 12. That's done. Now I want to find the vertex. To find your vertex, we have to do a little bit more work, though. Okay? It's a two-step process. Find our vertex. The vertex consists of two values, an h and a k. So, step 1 is to find the h value. The h value is found using the formula negative b over 2a. So the b value in this case is 8, so I'm going to put 8 right here. And the a is not there, so that means it's a 1. So we have negative 8 divided by 2, which is negative 4. So I've just found the first part of my vertex, the x part, which is negative 4. Now to find the k part, we're just going to take that number that we got and plug it into the equation over here for x, and that will tell me the y value. So y is equal to negative 4 squared plus 8 times negative 4. And I'm running out of space, so I'll put my plus 12 right here. And then we just need to simplify this. So when you're doing this, make sure you follow your order of operations. So we do exponents first. So that's going to be y equals 16. Negative 4 to the second power is 16. And then 8 times negative 4 here. And then plus 12. after you do your power, then you do your multiplication. So we have 16 minus 32 plus 12. And then we're just going to add and subtract from left to right. So 16 minus 32 is negative 16. And then negative 16 plus 12 is also negative 4. That's interesting. That doesn't usually happen when they're the same, but it can. So I get negative 4. And there's my vertex. So that one took a little bit longer, but the steps are to find the h, do negative b over 2a. To find the k, take your answer for h, plug it into the equation, and solve for y. Make sure you're careful with following your order of operations when you do that. And there's our vertex. So now I've got my y-intercept, I've got my vertex, and technically now we have enough information to graph this, which is what I'm going to do next. Now, then I'm going to do something else. Now, you don't necessarily need to do this, but it might help you make sure you get the correct answer. And that is, I'm going to notice the fact that my a value is positive. So I have a happy face parabola. Okay. So let's go ahead and graph this now. So my y-intercept is at 0, 12. So that's way up there. My vertex is at negative 4, negative 4. And now I need to connect these dots with a happy face parabola. And you have to remember that this one is the vertex, okay? So if that's my vertex, then it would have to look like this. I missed the dot. Let me try again. This one. And it should be symmetrical. So, you know, you should have, we would imagine there'd be another dot over here right across from that midline, so that we have a nice happy face parabola. Okay, so there it is. We have our y-intercept, our vertex, and our parabola. Step 1, identify your y-intercept. Step 2, find your vertex by doing negative b over 2a to find the negative 4. And plug that into this equation to find the k. Once you have both of those, you could plot them both and connect the dots with a parabola, making sure that the one that's the vertex is the vertex. Sometimes somebody might make a mistake and connect the dots like this. The problem with doing this is not only is it a sad face parabola when we know it's supposed to be a happy face. That's one problem. The other problem is that the way the person drew this one is they made this the vertex. But that wasn't the vertex. That was the y-intercept. The vertex is supposed to be the other one. So be careful how you connect the dots. And that's one of the reasons why, you know, paying attention to the fact that it's a happy face parabola might help you with that. Okay? So that is how you can graph a quadratic in standard form. Find the y-intercept, find the vertex, and then make it happen. So let's do a guided practice. So that means we're going to do this together. So first of all, let's identify the y-intercept. You probably don't even really need to pause the video to do this, but if you do, that's okay. Pause the video. But think for a moment, what is the y-intercept? The y-intercept would be 0, followed by this number here, which is 0, 6. Next, we want to find the vertex, okay? Now for this one, you're going to need to pause the video and work it out a little bit. And just to warn you guys, you are going to end up with a decimal here. And my advice for this problem is you're going to get a fraction. And so in the process, instead of doing a fraction, just divide the top number by the bottom number, change it into a decimal, and work with decimals. It'll make things a little bit easier. Okay, but right now I want you guys to pause the video here, and I want you guys to see if you could find the whole vertex. And yes, you are going to be getting fractions, and I recommend you just change it into a decimal. It'll make things a lot easier. Okay, when you unpause it, you'll see the solution worked out. So here's our answer. You should have gotten 2.5 and 12.25 for K. Now for the h, you plug in the b and the a into the negative b over 2a formula. The negative on top and negative on the bottom cancel, so it comes out to be positive. And then basically you have 5 divided by 2, which is 2.5. Now that's what we're going to plug into our formula here, the equation. Now you are going to do the squaring first. So if you square 2.5, you get 6.25. But the negative doesn't go away. When we square things, doesn't the negative usually go away? Yes. But in this case, the negative is not inside the parentheses. It's not being squared. The negative is just sitting there in the front. So the negative does not go away. It's negative 6.25 as a result. And then we have 5 times 2.5, which is 12.5. And if you combine the 12.5 with the negative 6.25 and the 6, you end up with 12.25. So there's your vertex. Write that down. Now the next thing I would like you guys to do is I'd like you to decide, is this a happy face parabola or a sad face parabola? Well, the way that you can tell that is by looking at the number in the front. And since my a value is negative, it's going to be a sad face parabola. So keep that in mind when you graph it, which is step C. So now I want you guys to pause the video here, and I want you to see if you can accurately graph this. Now, graphing decimals is a little bit of a pain in the butt. Basically, it just means, like, to graph, to find out where 2.5 is, you just go over 2 and then a little bit more for the 0.5, but just not all the way over the next point, right? So that's pretty much it. Same thing with the 0.25. We're not being really precise here. Guesstimating. So go ahead and pause the video and make a graph. And I would be getting something that looks like this. Here's my vertex, 2.5 at 12.25, and my y-intercept is with a sad face parabola. So here we have a student practice for you. Same thing, but this time we're not going to go through it step by step. Just going to let you guys go ahead and try to do it on your own from beginning to end. So see if you guys can find the y-intercept, vertex, and parabola. Graphing, that is, and then pause the video, and then when you unpause it, you'll see the solution worked out. So here's the final result. The y-intercept would be 0, negative 7. The vertex is negative 3 and negative 16. Here's the work for that, where I plugged in the b and a to find the h. Then I took that answer and plugged it in over here to get my y value for the vertex, which is the k value. And that goes here. So my vertex is negative 3 and negative 16. Since the number in the front is a positive a, we have a happy face parabola, and then my vertex, negative 316, is down here on the bottom. My y-intercept is 0, negative 7 right here. Connecting the dots with that happy face parabola, we're good to go. So there's your solution for that one. All right, let's move on to another topic here. Let's talk about the roots again. Now, we've already done this before. The roots are also known as the x-intercepts, which we talked about. They're also known as the zeros. So you might hear any of those 3 words being used to describe the same thing, which is the place where your graph touches the x-axis. And at those points, your y value is 0. So if I were to take my equation up here and plug in 0, how would I solve for x so that I know what the roots are? Well, that's the quadratic formula. So the way that you find the place where your graph touches the x-axis is by setting it equal to 0 and using the quadratic formula, and that will tell you what the roots are. Okay, so let's go ahead and do that a little bit. So I've got over here a graph, and I want to know what are the x values where this parabola is touching the x-axis. Okay, so how do we do that? Well, to find the place where it touches the x-axis, first of all, we plug 0 in for y, and then we solve for x. Now, how do you solve for x whenever you have a quadratic equation set equal to 0? The answer is the quadratic formula. So we do x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so we're going to plug in our b value, we're going to plug in our a value, and then we're going to plug in our c value. The a is 1. There's just a lot of extra scribble in there, so it looks confusing. All right. So we simplify our 4 parts first. So this is -8. This is 64. That's 48. And then 2 is on the bottom. -64 minus 48. What would that be? Calculate that real quick. So 64 minus 48 would be 16. Square root of 16. Well, the square root of 16 is 4. Interestingly, a lot of times after students take the square root, they put it back on here so they would have the square root of 4. That's wrong. After you take the square root, that symbol goes away, just so you know. Now in this case, since there's no square roots on there, we can go ahead and we can just split it up into 2 problems. One where we do -8 plus 4 over 2, and one where we have -8 minus 4 over 2. So this one, if you do -8 plus 4, it's -4. Divided by 2 is -2. And then for this one, -8 minus 4 is -12 divided by 2, which is -6. So these 2 places here where it touches the x-axis are -6 and -2. Those are our final answers. And so that's how you find the roots. That's how you find the place where a quadratic equation touches the x-axis when it's in standard form. Okay? So you guys try one. Go ahead and see if you guys can find the x values, these places here where it touches the x-axis. So here's the solution. You should have gotten 2 and -7. Now, you might, the one place where it's common to make a mistake is that we have a minus here and then this is negative. So when you put this together, you have -28. If it's minus a -28, it becomes plus 28. So you should have had the square root of 64, which is nice. It just comes out. You can just find those 2 answers. And just so you guys know, sometimes when you're doing these problems, you could end up with a number in here that is not a very nice square root. Now, last time we did these problems, we tried breaking them down if you could. If you're just being asked to graph it or something, what you could do is instead of doing all that work is you could just use a calculator and change this into a decimal and just do the rest like that. But it's not necessary, just kind of throwing some thoughts out there at you guys there. Right. And that does it for this particular lesson. So, till next time.